Hello everyone, welcome to my channel. So here in this video we are going to go through all the important definitions, formula, properties, questions as well, as example from the syllabus of second semester mathematics for the streams CSE and civil mechanical, as you can see on the screen, and for the mentioned paper codes for VTU. Okay, and so in this particular video, this is going to be a very crisp one, and before the examination, to revise all the important property formula, this is going to be the most important one. And not only that, as you can see, I have also kept the last year question paper for these streams as well. So parallelly we are going to see the questions from the mentioned parts as well. Okay, and this PDF, I'll provide this PDF. If you want, just let me know in the comment section, and you are going to see the PDF as well. And I believe this is going to help you very much before the examination. So request to all of you, if you like this one, so do like the video and subscribe the channel for future contents, and I have decided that I'll be covering the important previous year questions and practice sessions for VTU as well, to help you before the examinations. So let me know in the comment section those paper codes from mathematics and other topics as well that you want to be covered, and do share among your friends and juniors as well. Okay, so without wasting further time, let us start. Okay, so as you can see, so here I have kept one single PDF covering the syllabus of all these streams for second semester mathematics for all the engineering students. The thing is ki I have noticed one thing, ki the syllabus is mostly same, like the modules are mostly same in the syllabus. There are one module, there is actually one module which is different in the streams. Otherwise most of the syllabus is same. For example, in CSE there is vector space, linear transformation and all, as you can see in the question paper as well. Some questions are there. Numerical method is one of the topics which is there in all the syllabus. There is PD in some stream, there is a Laplace transformation in some stream, and like this. So okay, so I have made this PDF and I can see you the content as well. Multiple integral is there, beta gamma function is there, vector calculus as I have said, Laplace transform is there, PD is there, vector space and linear transformation is there, inner product space, as well as numerical method is there. So as you can see, I have covered everything. So you just have to pick your topic according to your syllabus, and that's it. Okay, and do not worry, I will share this PDF. If you want, do let me know in the comment section, and I target to have at least 50 likes for this video. Okay, anyway, so let us start from the first topic, that is multiple integral, as you can see on the screen. And so multiple integral, definitely we start from double integral. So what is the scene is ki we have been doing the single integration for single variable in our school standard in class 11 12, mostly in 12. So here we have double integration, that is here two independent variables will be involved together, x and y. Say one or two steps that we have to be very careful in the beginning of the solution from any question from double integral, and I'll see the question, I'll show you the question paper as well. That is the diagram. The very first thing that you have to do, that is you have to draw the diagram so that you can identify the region in which you have to integrate, mentioned in the question, right? And then from double integral there are two categories. Number one, let me show you here. Number one, that is change of variable, as you can see, and number two, the another category is that is change of the order of the integration. Okay, so in change of variable, what you have to do, for example, the given question is the question is given in x and y, the variables are x and y, and some transformation is given as well in the question in u and v. So you have to do the transformation, and then you have to integrate the question in terms of u and v as well. But remember one thing, while changing the variable of the double integration, the thing that is required to connect the two variable system, and that is the Jacobian, right? So here it is, the determinant is called the Jacobian determinant, and here it is written as well. So always remember to calculate the Jacobian as well while changing the variables, right? Now this is one category of question, and let me just show you in the question paper as well. This is from multiple integral. You can see the this is change of order of integration, and I'll come to that later after this. And here we have this question is this is the mechanical question. So for mechanical engineering stream we have this, and this is the change of order of integration, and again we have the change of order of integration, right? So this is the thing. Okay, so and we have change of variable as well. This 2a for civil engineering students, 2a, this is the change of changing into polar system, that is the change of variable category question, right? So as you can see, so this is a very important one. And as I can see in the previous year, the change of order is there mostly, so change of variable is going to be important for this year as per my prediction. Okay, and for change of order, what we have to do, I just have to check once the thing. Yes, here you can see the polar coordinate wala question is also there, how to change the order. So I have not only the formula, the property, the definition, I have also kept some important question in between, so that you can revise it quickly before the examination, so that you do not have to go anywhere. In one single PDF you can revise the formula, the property, as well as some practice questions to connect the things. Okay, so next I have the change of order of the integration. In that, what you have to do, sometimes suppose the integration is given like this. Let me show you the CSE question for the second semester. You see the question 1b. So here if we see the question, they are asking us to integrate with respect to y first. Also if you see the limit as well, you can see the limit is in terms of x. That means this is the y limit, this is the limit of y. So according to the question, we have to integrate with respect to y first and then with respect to x. But they have mentioned here changing the order of integration. That is, so what you have to do to solve this question, first you have to draw the diagram by seeing the limit of y, and then you have to change the order of the integration. That is, you have to integrate with respect to x first and then with respect to y. So the limit you have to pick from the whatever region you will have here, you have to pick the x's limit first, then the limit of y. And we all know the x limit is taken from left to right direction. That is, the leftmost point of the region is the lower limit of x, rightmost point of the region is the upper limit of x, and the limit of y is taken from upward direction. That is, the lowest point of the region is the lower limit of y, and the highest point of the region is the upper limit of y. That is it. Okay, so be very careful while changing the order, just whatever I have said, and also while changing the variable, right? Do remember to calculate the Jacobian. By the way, from all these topics, dedicated one-shot lectures are already there on the channel. One lecture is enough to cover the concept, the formula, the property, as well as the questions. If you see the lectures, I have put the links of one-shot in my the thing is in my channel, all the lectures are made in the form of one-shot only. In one lecture you'll be having everything. The lectures are slightly longer, and that is the reason, because I have to cover all the things in one lecture, so they are slightly longer, 40 minutes, 35 minutes, that you can bear, I guess. So the links are there in the description. You can definitely go through those lectures to get to practice the best before the examination, right? Okay. After that, we have triple integration, and there are questions from triple integration as well. Here, see in the CSE question paper, there is question. See in the civil question paper, there is question from triple integration. The first question, as well as in the mechanical engineering question paper as well, the question is there from triple integration. So in triple integration, it is relatively easy. See, they will not increase the difficulty in all the possible ways, since here we are having three variables x, y, and z. So the function and the limits will be on the easier side. So just carefully do the integration. While integrating with respect to x, take the limit of x. While integrating with respect to y, take the limit of y, and same for z. You can see the formula here, the representation here, and that is it. Okay, so let us go forward. Proceed forward. One question is there as well, to understand the concept and to link the things between. Okay, next we have one of the most important topic, and that is beta gamma function. Again, the dedicated lecture is there from beta and gamma function, in which you have the definition of beta and gamma function, the important properties of beta and gamma function, the proofs of the properties, as well as the most important questions, the previous year questions as well, right? Okay, so from beta and gamma function, what you have to do, this is for both the things, for both beta and gamma function, what you have to do, that is, first you have to remember the definition of gamma function. Remember, this is a special type of improper integral, and n should always be greater than 0. Integration 0 to infinity e to the power minus x into x to the power n minus 1 dx gamma of n ka definition. Next, we have the properties of gamma function. Each and every property is important to solve the questions, as well as they are important from proofs perspective as well in the question paper, right? And this is important one. These properties are used to solve mostly like the 80 to 90% of questions from beta and gamma function. By the way, this fourth property, this is also called as a duplication formula. And remember, this property is only applicable for the n which is lying between 0 and 1, that is fractions only, right? This fourth one. And the last one, very very important, that is gamma half is root over of pi, mostly used in the last line of the calculation where we have to find the final value of any gamma function question. Okay, next I have kept here one or two questions again to just revise quickly. And then we have beta function. Same for beta function. In gamma function we have one parameter, only n. In beta function we have two parameters, m and n, as you can see. And remember, m and n both should be greater than 0. And this is the definition: 0 to 1 integration x to the power m minus 1 into 1 minus x to the power n minus 1 dx is the definition of beta function. And then we have again the important properties of beta function, as you can see here. And this is one of the most important property, and you will just see the thing. These are some tricks that you will also get to know as much question as you solve, and you will also be able to find this kind of tricks. That is, if any question paper there is a question of sin theta or cos theta like this is a very important one in the civil engineering question paper. As you can see, whenever a question is there from sin theta and cos theta, and the limit is 0 to pi by 2, and the integration limit is 0 to pi by 2, we 200% sure ki we have to use this particular property to solve that question. Very very important one. Okay, and in the lecture that I have said in and there you will find the proofs of this important properties as well, the proofs of those important properties, right? And then finally this is also very important, that is beta half comma half is, and the value is pi. Again, this is used in mostly in this last line to find the final value of the beta function question. And not last but not the least, and that is the important relation between beta and gamma function. And I do not know what kind of symbol that I have made there. I wanted to make a star, but I do not have the mouse right now. The mouse is not working, so the touchpad that I am doing. Okay, so anyway, so the relation between beta and gamma function, that is beta mn is equal to gamma m into gamma n divided by gamma of m plus n, and this is important for solving questions, because the question that I have said, this cos theta sin theta wala, in this also you have to use that property. And not only that, let me just show you. And dedicatedly they can ask you to show or the proof of this particular property, right? You can see here in the CSE question, you can see the same thing in the mechanical engineering question, that is derive the relation between beta and gamma function, as you can see, right? So very very important from exams perspective, this one, right? Okay, next, and I have put some question here, as you can see. And okay, so now we are starting the next module, and that is vector calculus. Again, I have said this is a compilation of all the modules for different streams. The thing that you have to do, you have to pick yours, that's it. Okay, and so here we are starting with starting from vector calculus. As you can see, vector is one of the most easiest thing we can say, because we have been solving questions, we have been dealing with vectors from our school, and in physics it was also there. Same things we have here also. This scalar function, vector function, all these things were there, nothing new. So let me just quickly brief the things that you have in your syllabus. Okay, so firstly, this operator that you need to know, this is called nabla operator. I hope all of you know the name. The name is important. What I've said, nabla, N-A-B-L-A, nabla operator, and it is defined like this: vector differential operator or nabla operator. This is very very important, and this is mostly used in all of the parts of this vector thing, right? For example, this is the formula of gradient, very, and also again I am saying this, there is a dedicated lecture from gradient, curl and divergence in my channel. It will cost you 1 hour only, no money, nothing, zero, just 1 hour only. And after completing the lecture, you will notice this thing, ki you know all the concept, you know how to solve questions from this gradient, curl, divergence, because I assure you there are almost 10 plus questions in one lecture, one single lecture from gradient, curl and divergence, with all the concepts, formula and everything. Okay, and the link is in the description. Okay, so from gradient we need to remember this formula of gradient, that is gradient of any scalar function. Phi is defined like this: del phi del x into I cap, del phi del y into j cap, del phi del z into k cap. Okay, and we have a question here just to verify this thing once, and you can see it from here. And next we have divergence, and D for divergence, D for dot product. I remember like this, from my school standard only, from my school only, that is D for divergence, D for dot product, C for curl, and C for cross product. I used to remember like this only. Okay, in divergence we have to do the nabla dot V vector, which whatever vector we have to find the divergence of, just do the dot product with nabla, and it will be this will be the formula for that. That is, for example, the vector is defined like this: v1 I cap plus v2 j cap plus v3 k cap. Again, it can be different. Suppose you have studied a cap b cap, a cap plus ai cap plus bj cap plus ck cap, like that, or f1 f2 f3, whatever it is, but the formulation, the representation is this only, right? And next, one of the most important thing that you need to remember, that is solenoidal vector. And when do we call a vector solenoidal? When the, yes, you have said it correctly, that is whenever the divergence of the vector is 0, the vector is called solenoidal. One question is there to verify this thing. Okay, and next we have, as I have said, that is curl, and D for dot product, C for cross product, I have said. So in divergence we do nabla dot V, in curl we do nabla cross V. Okay, and here it is the determinant to expand the cross product. We all know that, and how to expand the determinant I do not have to tell you. You all know that. I cap into this into that, matlab in this way we have to do is do this, right? This and then iske saath ye, like that. Okay, so and here we have one question as well for you to just remember the expansion of the determinant quickly, and here we have that one. And also remember, that is if the cross product of the divergence, that is rather the curl, if it is 0, then the vector is called irrotational vector. Very, very important from exams perspective. And quickly, if I move to the question paper now, as you can see, you will see many more questions, many questions, bhar ke questions from this curl divergence part. As you can see, this question number 3b, the vector f is given like this, and you have to find the divergence of f and curl of f. And let me mark my word, this question is solved in the dedicated lecture of divergence, curl, and curl divergence and दूसरा क्या gradient lecture on my channel. Right, this question is already there. So whoever student watch that particular lecture before this examination, they scored full marks, 200%. And this is the question paper of CSE. Let me show you from triple E. That is, here is the question 1b, as you can see, from divergence and curl. Same question it is given here, and I'll come to this thing later. And okay, and then we have the question paper of this is mechanical engineering, and here is a question from question number 3 C as well, and 3a as well. Okay, all these questions, this directional derivative, rather I'll come to that thing later. All these questions are already solved there, okay. And then again we have some question here as well from curl and divergence. Okay, so you can see now you'll be able to solve this question very easily. And these questions are compulsory questions. They are definitely there. One lecture is enough to complete or to solve all these questions, I bet you. Next, okay, next we have the application part. Okay, so for here we have the cylindrical and spherical coordinate system, that is in 3D, 3 dimension, that is XYZ can be changed into different coordinate, that is the Cartesian coordinate system in 3 dimension can be changed into a different coordinate system as well, that is cylindrical and spherical. And here are the coordinates for that. We can say r theta z for cylindrical and rho theta phi for spherical. Okay, so this is the thing that you have to remember. And then there are some questions as well to understand this thing, not that important. If you can skip if you want, but let me just give you one more point from this part, that is okay, that is you have to do, you have to do this kind of question, and that you will find in the lecture as well. That is the application based question. I want to show you okay, this one, where this work done type of question, this question number 4a, this type of question. right? Again, these are very straightforward questions, and you can see these kind of questions in the lecture as well. Okay, next we have vector integration. In vector integration, again it will be done in the like following the simplest way. For example, f dot dr, if you have to integrate it, just remember f is the mostly the vector. It can be work done, it can be it is generally a force, and from force we have taken the f letter. Otherwise it can be any vector will be mentioned in the question. And the r vector, it is the position vector, xi cap plus yj cap plus zk cap kind of thing. And some question is there that I was saying about the work done kind of thing. Okay, so here it is, I forgot, I have kept it here. So this kind of questions are very important from exam as well, and here you can have one or two. Next we have surface integration. From surface integration you need to remember the form of this thing. Here it is, and again there is one dedicated lecture, line, surface and volume integration on the channel, in which you will have all the questions, all the formula, all the properties. Once again, everything I have provided in the description, the links of those particular lectures. Okay, next we have here the three theorems are there, Green's theorem, Stokes theorem and Gauss divergence theorem, and you have to remember the form of these theorems. Let me show you one or two questions in the way they come to the, not in CSE by the way, not in CSE. Like here we can see the question, using Green's theorem evaluate this, right? So you need to remember the statements of Green's, Stokes and Gauss divergence theorem, as well as questions from that. Now there can be two types of questions by the way. Let me show you. Here it is, one more question using Green's theorem, as you can see, and let me show you here as well, using Green's theorem. Okay, so here I was saying there can be two types of question from Green, Stokes or Gauss divergence theorem. One is calculate or evaluate type of thing, right? In that type of question, they will either mention the left hand side, mostly they mention the left hand side of the theorem, and you have to solve the question by calculating the right hand side of the theorem. For Green's, say I am saying this. And one more type is verify the Green's theorem. The previous one that I have said is the calculate or evaluate kind of thing, and the second category is verify. For a verify type of question, what you have to do, you have to separately calculate the left hand side, the value that you are getting from the left hand side, as well as the value from the right hand side. There are dedicated lectures from Green's, Stokes and Gauss divergence theorem on the channel, and in which I have solved both this type of questions, evaluate as well as verify. Go through those important questions are there. They will 200% clarify your doubts and solving procedure. Okay, next. By the way, in Green's theorem we have this thing, in Stokes theorem we have the cross product, as you can see, and in Gauss divergence theorem we have the dot product, and the question is, one question is there to understand, as well as the formula, the statement is also there. Next we have Laplace transform. Laplace transform is not there in all the syllabus. I guess it is there in, let me show you the question. Here it is. Okay, so this is for EEE. Okay, and here are some question number 5 is from Laplace transform, you can see, and yes, here are the things. And Laplace inverse is there, convolution theorem is there. Using Laplace you can solve the differential equation as well. Okay, so many things are there. By the way, recently let me just give you some source for this. I have solved too many questions from AK2 previous year question paper, right? And there are also some important question of Laplace transform. If you can go through those solution of those, and the timestamp is there, so you will be able to identify the question of Laplace transformation. Why I am saying this, because in those, like in the solution of those question paper, the important types of questions are already solved. So for a practice purpose you can definitely go through that. Next, from Laplace transformation, first the thing that you have to remember is obviously the definition of Laplace transformation to 100%. Okay, by the way, this is not directly important to solve the questions, but yes, you need to know definitely, right? Okay, next, the important properties like linearity property, scaling property, shifting property. Two shifting properties are there, this one and this one. Okay, and then finally for the differentiation. By the way, for differentiation you need to remember, I hope some question will be there, anyways I'll check it. Okay, anyways, I'll check it, or otherwise I'll update this, or let me just narrate it here. That is, here is only here is the Laplace transform of only first order differentiation, but you also need to remember for the second order as well. Okay, I'll put it here. I'll just write it, okay, and put it here. For second order also you need to remember the Laplace transform, for the second order differential, okay. And for integration also you remember this formula. And just recently, before like 2 to 3 days before, I just solved a question of just AKTU second semester examination, where I have solved one question using this particular property. I just remember, okay. Next we have some question. Next we have inverse of Laplace transformation. You should remember this one. Next, convolution theorem, one of the most important thing, convolution theorem. You have to remember this one, okay. And I have kept one question here from convolution theorem, and you can solve your question as well from your previous year question paper, but very important, very important convolution theorem, okay. Next we have PDE, partial differential equation. Again, this is not for all the streams, some particular stream it is there. And from PDE you need to remember, for civil engineering it is there in the syllabus. For PDE, firstly you need to remember the, obviously the notation, the partial differentiation notation, okay, not the total differential but the partial one. And maybe there will be there can be one variable, there can be two variables, but mostly there will be obviously two or three variables, but mostly two variables we are dealing with. And what you have to do, let me show you the question paper from this is not civil, I guess. No, this is mechanical, this is civil, this is civil engineering. Okay, so from PD, if you want to see some question, here it is. So mostly we'll get the straightforward questions like this, where you have to, so either two questions are there, as I can see, straightforward. That is, one is forming of a partial differential equation, and another one is solving a partial differential equation. That is just two opposite things. One from the solution you have to make the PD, and one from the PD you have to solve the equation itself, okay, to find the solution. So for that we have some methods here. Lagrange's method is one of the most important one, and some here it is, Lagrange's method to solve the PDE, it is there. And you have to remember some important equation as well, like heat equation, wave equation, it is written here as well. And some question is there to solve it quickly, and that's it, okay. Next we are starting a vector space and linear transformation. Again this is for a CSE branch, okay. And we will see some questions directly from this part, from subspace, from linear combination of vectors, from basis and dimension, from linear transformation. These are very important and famous things, from inner product space, like norms and all, everything, okay. So for that, what do you have to remember? Firstly, the definition of vector space. As you can see, the total 10 axioms, 5 with respect to addition and 5 with respect to multiplication. I have written the axioms here just to quickly go through it, and there can be dedicated question like that, ki check whether this is a vector space or not, or show that this is a vector space. For that we have to verify all these properties. So yes, this is important. Next, one of the most important, and at least you can expect one question from this particular subtopic, and that is subspace. And what kind of question? They will give you a subset in any vector space, and they will ask you to verify or to check whether that will be a subspace or not. And you remember, for that you have to just to verify two properties. One is alpha plus beta belongs to S, and one is C alpha belongs to S. For all, alpha beta belongs to S and C belongs to R. I hope you remember that. Two conditions you have to check: addition and multiplication. Addition of two vectors and scalar multiplication of a vector like this, C into alpha. Okay, so one or two questions I have kept here to check the subspace thing, and you can see in the question paper as well, subspace is always a important one. Here it is. Prove that the set is subspace, and believe me or not, dedicated questions are. And again, from vector space you just have to, for vector space and linear transformation, you just have to go through 8 lectures. Hardly it will take your 4 hours, max to max it will take 4 hours to complete the thing, in which you will find all the concepts and many important questions, including this one as well. Some practice session, dedicated practice sessions are there as well. All the links I'll provide in the description, so that you can go through it as per your requirement, okay. These questions, all these questions I have solved already on the channel, okay. But exactly these questions, okay. Okay, next we have linear combination. Again, linear combination of any vectors is given like this: c1 alpha 1 plus c2 alpha 2 plus c3 alpha 3 and so on. And then we have linear dependence, that is whether in a set of vectors alpha 1 alpha 2 up to alpha n or alpha r, whatever, one vector is dependent upon on the other or not. That is, one vector can be expressed as a linear combination of one or two vectors or more than two vectors or not. That is linear dependence, and there are some techniques to check it. By rank we can check it by finding the rank, or by calculating the value of the determinant in case of a square matrix. So all these things I have discussed in the lectures as well. Then we have one of the most important topic, that is basis and dimension. And always remember, for basis you have to check two conditions, whether it is linearly independent or not. For linearly independent, you should remember the thing, that is in the expression c1 alpha 1 plus c2 alpha 2 dot 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 plus cn alpha n, c1 c2 c3, these coefficients must be exactly equal to 0 in order to be linearly independent. Okay, and here it is written as well. Okay, and if c1 c2 c3 up to cn may say at least one is not equal to 0, then the set will be linearly dependent. So for basis you need to check two things. One I have said, that is linearly independent, and the second one that the set of vectors spans the entire vector space or not, that is spans V or not. If these two conditions are satisfied, then it will be a basis, and then you will find the dimension of it. What is dimension, by the way? Dimension is the number of independent vectors, or rather number of vectors present in the basis. That is the dimension of that particular vector space or subspace, whatever it is. Next we have linear transformation. For linear transformation you need to remember these two properties or definition of linear transformation. These are must. Okay, so one is t of alpha plus beta equals to t alpha plus t beta, and another one is t of c alpha equals to c into c will come outside, so c into t alpha. What kind of question you can get from this? They will give you a transformation. They will not mention that is a linear transformation. They will give you transformation, and they will ask you whether it will be a linear transformation or not. But verify whether it is a linear transformation or not. So to do this, do that verification, you have to check these two properties conditions individually. If it is satisfied, then it is well and good. Okay, next some things are there, and I cannot definitely include that as properties. What I'm saying, that is just mark my words, and otherwise I'll just update this thing a bit if possible before uploading in the as the PDF in the description. That is, there are this category of question from linear transformation. Yes, I have to include, it is not written here, but I will include it definitely. I just forgot, I think I forgot about that. That is kernel and image, and also I will include the thing that is rank nullity theorem, Sylvester's law of nullity. Okay, so all these things I will include here, very very important. Rank and nullity, kernel and image of a vector space, of a linear transformation as well, of a linear transformation. Okay, so I will include this in this PDF. I do not know how I forgot those things. I should have kept it here. Anyways, I will input it. Do not worry, and I will then upload the PDF. So do not worry at all. I'll upload it. I will include this, and then I'll upload. And then after that, one more thing. Yes, that also I'll include here, and you can see questions from that as well. That is from linear transformation to its matrix, and from matrix to its linear transformation. And also the thing that is whether a linear transformation is 1-1 or not, 1-2 or not. Again, I am saying this thing. Just you have to see 4 dedicated lecture from linear transformation to complete the entire these things. Whatever I have said. Checking of linear transformation, kernel, image, and 1-1 on-2 thing, matrix representation of linear transformation, inverse of linear transformation, everything you will be able to understand there. Okay, and then after that we have from vector space also we have 4 dedicated lecture: definition of vector space, subspace, linear dependence, independence, basis and dimension. That's it. So total 8 lecture to cover this entire module, hardly 4 hours. If you start watching it dedicatedly, 4 hours. Okay, so this is the thing, inner product. Next we have inner product, very small part, and there is not much there in the syllabus from this part. So what you have to do is you have to remember the basic properties of like the definition of real inner product space, and the process of finding the norm of a vector. the process of finding the norm of a vector. I have kept 1 or 2 questions to verify quickly, and the thing is Cauchy-Schwarz inequality, and you just remember the statement of Cauchy-Schwarz inequality, and that is it. Okay, that is it. Next we have numerical method, and numerical method is dedicatedly there in all the streams, in the syllabus of all the streams. Okay, so from numerical method, what you have to do, obviously you have to whatever methods you have there for solution of equation, there are regular falsi method, and here is the iteration formula of that, the convergence, the geometrical significance, advantages, disadvantages, everything. Otherwise, if you see the question paper, there are straightforward questions from each and every method of numerical methods. Like they will give you question and ask you to solve it by using this method, that method, like that. Okay, so for example, here we have one equation, solution of a equation type of question, transcendental equation, by using Newton-Raphson method. Okay, again all the methods are there. The dedicated playlist of numerical methods is there on the channel. In there you can find very like 10 to 15 minutes lecture from every method is there. Go through it quickly and you will be able to solve any question from numerical method. Okay, next we have, after Euler falsi, we have okay, so the way that I have made this PDF is the things that I have kept here: the iteration formula, convergence, geometrical significance, advantage, disadvantages, as you can see, and one dedicated question by mentioning the steps of that particular method as much as possible. Okay, then we have Newton-Raphson method. Again, we have the formula here and all the details of it, as you can see, and then one question. From interpolation, we have Newton's forward interpolation. You have to remember the formula, the expansion of Newton's forward interpolation, and then one question is there. Okay, and that's it. Then we have backward interpolation, same thing, Newton divided difference, the formula, the iteration formula, and one question as well. Lagrange's interpolation, the formula, advantages, disadvantages, and question as well. Then from integration, we have trapezoidal rule, the formula of trapezoidal rule. Be very careful about the formula of trapezoidal rule, advantage, disadvantage, and one question, as you can see. Then we have Simpson's 1/3 formula. Definitely you have to make the table while solving it, and dedicated lectures are there. I have said it many times, the degree of precision is very, very important for Simpson's 1/3 as well as trapezoidal degrees of precision. And then the advantages, disadvantages, and one question, as you can see. Simpson's 3/8 rule is there as well. Okay, so and after that, lastly we have numerical differentiation, and for numerical differentiation we have different methods definitely to solve the ordinary differential equation. That is Euler's method, modified Euler's method, and RK4 Dangi-Kutta 4 method. The formula is here, as you can see, Milne's predictor corrector method, and the formula and one question. So everything you will be able to find here in this one single PDF, all the important formula, property, questions, concept, everything as much as possible. Some part was missing, I'll include those part to complete this PDF once again, and I'll upload this in the description, upload this in the drive, Google Drive, and share the link here. Okay, so I hope this PDF will definitely help you to revise the things before the examination, and all the lectures from your syllabus. I'll share the links in the description, so according to your convenience you can watch those lectures before the examination. And request once again to share this lecture to this video as much as possible to your friends, your juniors, seniors as well. Share the channel as well for best possible future contents. Like if you like it, and subscribe to the channel to get the notifications whenever we bring dedicated lecture for your university. Okay, so thank you everyone, and all the best, and do comment if you want some particular thing or not in the comment section. And thank you for watching. Thank you, and all the best once again.